Hi, I am Deepana Govindaraja, undergraduate at University of Malta, Faculty of Information Technology. Today, the topic we are going to cover in this video is how to interface keypad with Admega32 for the password protection. In my last video, I have covered how to interface keypad. So here, let's go from how to check for the password. If you don't see the last video, please check it. I'll upload the description. I'll upload the link in my description. Okay, now let's move into the topic. Here, we are going to see for the 4x4 matrix keypad, but you can use the password protection for any kind of keypad. Here, the logic is the important one, not the kind of keypad what we are using. If you are using different kind of keypad like 4x3 or like that, just change the array number. That's only enough. Okay, now moving to the code. Here, if you see, there are 3 kinds of memory in Admega32. One is flash memory, that is 32 kilobytes. That is the large memory when compared to others, and 2 kilobyte SRAM and 1 kilobyte EEPROM. But the EEPROM is only the permanent memory. That means data will not be lost in the case of power failure. So the data like passwords have to be stored in the EEPROM for the permanent protection. If you store the password in like variables, it will be lost during the power failure. So you should remember that. And the main thing you have to remember is the write cycles tolerable for the EEPROM is only 100,000. That means 1 lakh. So you should not put the write cycle for the EEPROM in the for loop. Then it will end the life cycle very earlier. Thereafter, you cannot use that. So when you write the code, be mindful not to put the EEPROM write cycle in the for loop. This is not the case for the read cycle. You can use the read cycle for the unlimited time, but when you write the data on EEPROM, it's only for 1 lakh time. Okay, so first of all, what you have to do is, you have to write the code for the EEPROM read and write functions. So there are several steps you should follow when reading and writing data in EEPROM. EEPROM is mainly made up of 3 registers. Here in the below, I have explained one by one about the code. This is the article totally written by me in my Wordpress tips book. I will upload the link of my about this site in the description. If you want to read that, go to the description and find this article. I'll explain all the things here one by one. So in EEPROM, there are mainly 3 memories. That is address register, data register, and control register. And here I have explained what address register have to be done, data register have to be done, and control register have to be done. If you want to more clear about this, just go and read there. Here I have go into the topic straightly. So when you have a feeling that there are some steps for the write sequence and read sequence. When you're writing data, you have to wait until write enable bit becomes 0. That's what you have wait in the here. This is the function for the WP1 write, and here we have going to use CLI and SCI. This means we are using for the global interrupt. CLI means we are disabled. That means clear the global interrupt. Not any other interrupt can interrupt this function. We should disable the global interrupt because you will understand later when I explain why you should disable it. Okay, the first step, you have to wait until write enable bit becomes 0. Second step, wait until store program memory enable SPMEN in SPMCR memory control register becomes 0. Third step, write WP1 address to WP1 address register. That means to which address you have to write the data. That is what you have to write in WP1 address register. And in the fourth step, what you have to do is you have to write the data, what should be written in that address register in the WP1 data register. And in the fifth step, write a logical 1 to the MWE. That means master write enable bit. While writing a 0 to write enable bit in WCR, that means control register. So as the final step, within 4 clock cycles after setting master write enable bit, that means in the fifth step, you have enabled setting up 1 for the master write enable bit. After setting the master write enable bit, within 4 clock cycles, you have to set write enable bit because we are doing this way to prevent miswritings. If it exceeds 4 clock cycles, then it wouldn't be right. That's why we are disabling global interrupt. Because if there are any global interrupts coming in between these 4 clock cycles, then it misses the write. That's why we are disabling global interrupt during the write and read cycle. You should mind it. So now let's look at the how. As we have already said, we are waiting until write enable bit becomes 0. Because if it's in 1, it means something has been writing on particular address or any of the address. So then we have to wait until it finishes. So as we already know that it's in the while statement. So it will exit from the while statement when the condition false. So when it becomes 0, this statement will become false and exit from the while statement. That's the reason for this code. After setting 0, what we are doing is we are writing the address in the address register. At the same time, writing the data on the data register. Thereafter, we are setting master write enable bit. And finally, within 4 clock cycles, we are setting up the write enable bit. After writing the data, we have enabled the global interrupt. That's what doing to set. Okay, now let's talk about the read sequence for the WP ROM. Here also what we are doing is wait until read enable bit, write enable bit becomes 0. Thereafter, we are writing the address in the address register. Here we are going to read the data from WP ROM. That's what, there is no need to write any data on the WP ROM data register. And the third step, we are enabling the read enable bit. Here there is no need to make it more secure as the write sequence. Because in the write sequence, we are setting up the master write enable bit, and there are then we have to set up the write enable bit within 4 clock cycles, but there are no such restrictions for the read sequence, because if you are reading something mistakenly, then it wouldn't be a big issue. But if you have write something mistakenly, the data will be lost. That's why for the write sequence, it's more protectable. Okay, finally, we are reading the data in the data register. So what we have to return as the file is data register. So now let's look at the hard. Here also we are writing the function for the read, and here as the first step we are disable the global interrupt. Then we are wait until the write enable bit becomes 0. Then setting up the address register. Then setting up the read enable bit, and as the final step we are enabling the global interrupt, and data is read on the data register, so we are returning something. But for the write sequence, we are writing something, so no need for the return statement. Okay. Now what we have to do is we have to initialize this. So what we are doing here is the first one in WP ROM write, the first one shows, first parameter shows the in which address we have to write the data. And the second parameter shows what data we have to write on. And here you can see from this statement very clearly. Here we are passing two things. As the first parameter, unsigned char address, and the second parameter, unsigned char data. So here what means, in the address 1, we have to write 4. Here the 4 means that is the length of the password, what we are going to do. Here we are just initializing the setup. Thereafter, there is a way for you to change the password according to your wish at any number of characters. And in the second step, what we are doing is we are initializing the password. So from 2 to 5. Sorry, from 1 to 4. Because that means we have running 4 times. That means so for loop have to be run for the 4 times because the length of the password is 4. If the length of the password is 5, we have to run the for loop for the 5 times because we have to write 5 letters. So here what we are doing is in the WP1 write. In the address one, we have already write the in the address one, we have already write the address we have already write the length of the password. So from the address 2, we are writing the password. So that's why we are using I plus 1. Because if the I is 1, we have to make from 2. And here we are just initializing the value to here. So value of the initial password is 2, 3, 4, 5. By the way, you can set any password you like. There is no kind of such restrictions for that. And then what we are doing next is we are writing the function for the login. When you are logging, just think what you have to do. We have to enter the password. So there should be something to store the password which we have entered. So just determine what's the maximum number the password can be. Let's take, it can be maximum for 10 characters. So just set up entered password with the array of 10. Here, you just remember you can use any length that you can wish to make it as the maximum. So here as the initial step, we are setting the array entered password with all zeros. And also, the length of the password, we are initializing as the 0. Okay, now we are getting ready to enter the password. So as the first step, we are clearing the LCD display. And in the LCD display, it's just showing in the password. And then the cursor should be set to for the next line. If it's 0, 0, cursor is in the first point. And if it's in the 1, 0, cursor is in the second line. So now the user is going to type the password. So in the variable length, we are going to get the length of the password. Here, that's what we are doing. Length is equal to get password into entered password. Entered password is the array which we have already created. And get password is the function. In later, you will see that function. Here, only just remember, we have used get password function. And then what you have to do? Here, we have entered the password. So that's what we have using to get password. And thereafter, we have just calculated the length. So then what the next step? We have to check the password, whether this is the real password or not. So that's the next function we are doing. And if it's true, that means if the password is correct, then the procedure you want to make will be happening thereafter. You can write whatever the function you wish to do after for the successful login. And here, if it's false, you have to make it for the another chance. Okay, now what we are going to see is get password function. You might remember we have used the get password function in the login. That's what we are using here. Here what we are going to do is here we are passing the password, every character, one by one. So we are first initializing counting variable and every key. And what we have to do is, in the login function, we have determined the maximum number of characters of the password. We have determined as the 10. That's why we should write the for loop for the 11 characters, because after writing the password, we should press something, right? Like enter, like this. That's why we are running the function for the 11 type. If you determine the password is 15, then you have to write the function for the 16 for the for loop. Okay? Then what you have to do is, for every key, you have find the key file. That means that is the function you will study in the previous video. That means interfacing keypad with the Admega32. So when you enter each character, every character is stored in the variable key. And here we have using the hashtag as the enter key. It's just our assumption. You can use any key as the enter, but in our case, we are using hashtag as the enter. So if the enter character by the user is hashtag, that means if the key is the hashtag, then you will exit, because you have entered the password and press enter. So you have to exit from the statement. So to exit from the for loop, what you have to do, it's back. So here you are putting back. So it will immediately exit from the for loop. Else if, that means if you didn't press enter, then you have to check counting variable is not equal to 10, because counting variable is starting from 0 and the maximum character is 10. So counting variable should be maximum 9 and the 10th character should be enter. So you have to check counting variable is not equal to 10. If so, you have to show something like if the password is wrong, or just give a chance to delete and make them, or like that. And if both are not, that means you didn't press enter key and you have furthermore chances, that means counting variable is not equal to 10, then what you have to do is that's written here. What you have to do is the password counting variable. That means password is the array we have created And in the array, 0th character, first character, second character, you might know array starting the index from the 0. Counting variable also here we have start from 0. So in the password in the 0th character, first key entered will be stored, and for the first character, second character, like that, it will be stored. And you might notice when you are entering a password, the value will not be displayed strictly, just asterisk will display. That's why we are printing as LCD display as asterisk. Okay, and as the finally we are returning counting variable. That means we are returning the length of the password from here. That's what we are getting. Length is equal to get password. In the return statement, we have return the length of the password. That is the counting variable. Okay. Now, what we have to do is we have to write the function for the check password. And if the check password, what we have to do is we are passing the length of the password and the password. So it will be easy first. Just check whether the length of the password you have entered and the length of the original password are same. And you might remember we have stored the length of the original password in the address 1. That's what you are checking, whether the data in the address 1 is equal to the length. So you are just reading the data from the WP-ROM from the address 1. And you are checking whether they are equal. And if it's not equal, just display the error message as unmatched length. And if both are equal, then it will be moved into the else statement, so that what we have to do is we have to check character by character. That's what we are going to run the for loop from 0 to length. Because we don't know what's the length. So as we have in the first step, we just notice that both are same length. So we have running the for loop for the 0 to length. Since it starts from the 0, no needed to put the equal sign. If you have start from the 1, then you have to put the equal sign. Here we are going to check each character by character. So what we are doing is the password, the key we have entered, and the data in the WP-ROM, both are equal or not. You might remember in the WP-ROM, in the address 1, length of the password is stored. And from address 2 onwards, the password is stored. So you have to check from the address 2. But you are running the for loop from 0. That's why we are plusing 2. And if any single character mismatches, we have to show the error message as wrong password. Because if a single letter mismatches also, there is no further needed for that. So showing wrong password. And we can return the function. There is no need for checking the remaining things, because definitely it will be false. So we are returning false. If all the characters matches, then we are displaying as the correct password, and 1 will be returned. That means the true will be returned. Then what you have to do in password function, there should be some options for changing password. because there will be definitely some need for changing password. So what you have to do, when changing the password, there should be 2 times the password should be asked, right? That means the second time for the confirmation. That's why we are using all the terms for the 2 times. Desired password 1, then these are the variables. And for the initializing, we are setting all the things for the 0. And we have cleared the LCD display and setting the display cursor for the line 1 and displaying new password. And then cursor is moved to the next line. That means for the second line. And here we are getting the password. And this is the function called get password. That is what we have seen earlier. Get password function, you might remember. And the get password function returns the length. That's what we are storing the variable length 1. And thereafter, we have asking for re-enter the password, and the password again enter. We'll move to the function get password, and it will return the length 2. And finally, what we have to do is we have to compare both passwords are the same or not. That's why we are passing to this function compare, and we are passing all 4 as the parameter. If the if statement returns true, that means both passwords are same. Then you have to change the password, right? So what you have to do is, in the WP-ROM, in address 1, there is the length of the old password. So it should be rewrite. So in the address 1, length of the password is rewrite. Since both are the same password, writing length 1 or length 2 will not be a matter. In the address 1, you have to write the length. And from the address 2, you have to write the password. So from the address 2, you are entering the desired password. If the comparison is wrong, that means the password you have entered and re-entered both are different, then you should not rewrite with the password. So you should display the message as the failed operation. Okay? Now, what we have to do is, in the compare function, in the change password, we are using the compare function. So as the final step, we should write the function as compare. So that's what we are going to see lastly. In the compare function, we have passing 4 parameters, length 1, length 2, and for the 2 passwords. So as the first step, we just check both lengths are same. If not same, there is no for the second doubt. It will be both are definitely different. So we are returning false from this function. If the length are same, what we are going to do is we have to check each character by character. If it's any of the characters is false, then we can simply return false. And if all the characters are same, then only we are returning 1. Okay. I hope you might get some idea about this. By the way, if you have any doubt about this, you can contact me over the LinkedIn. My LinkedIn address is also Tibana Govindaraja. You can contact me over the LinkedIn at any time. Bye-bye. Meet you in the next video.